Now we will solve the problems on the stress losses of the pre-stress. So in the question you can see this. It is the pre-tensioning concrete beam where the dimension of the beam is the 100 mm by 300 mm deep, is a pre-stressing straight wires carrying an initial force of 150 kilonewton at an eccentricity of 50 mm. They are given the eccentricity as 50 mm. The modulus of elasticity of the steel and the concrete are 210 and 35 kilonewton per mm square. So modulus of the steel will be higher, so that is 210 kilonewton per mm square, and the concrete it is 35 kilonewton per mm square respectively. So you can take it as ES and EC respectively. So next is you have to find out the estimate the percentage of the losses of the pre-stress in the steel due to the elastic deformation, where the area of the steel wires in the concrete in the PSC section, whatever the steel wires are there, that area is given as 188 mm square. So later, by reading the questions, you take down the data. So that data is P is 150 kilonewton, and E eccentricity directly they are given. If not given, you take depth divided by 6, so that finally you will get around 50 mm. That is an E. So area it is 10 into 300, so it is, you will get 3 into 10 to the power of 4 mm square. So that is an area. And I, so BD cube divided by 12. So by using that formula, you will get the I is equal to 225 into 10 to the power of mm square. So what you have to estimate is the first you have to find out the modular ratio. So modular ratio is the Young's modulus of the steel divided by Young's modulus of the concrete. So Young's modulus of the first you find out the Young's modulus. Later we can find out the percentage of loss in the steel and the stresses in the steel. Okay, so that one, so we will find out the that is the Young's modulus. Young E, what is that, alpha E is equal to ES divided by EC, that is 6. ES, they are given the Young's modulus of steel, that is 210, that divided by EC 35 kilonewton per mm square. So you will get the 35 you will get the modular ratio as 6. So find out the next later, the second one, you find out the initial stresses in the concrete. So initial stress in the concrete, that is FC, FC, that is initial stress in the steel, so that is Fs is equal to P by A. So P, it is given the load at the top they are given as 150 kilonewton. Take that load as 150, convert that into a newton. Okay, the area of the steel, initial stress you have to finding the steel, so that's why you have to take the area of the steel, that is they are given in the question, that is 188 mm square. Okay, so initial stress in the steel you get the 188 newton per mm square. Next you find out the stresses in the concrete FC, so that is P by A, same, but area here P load you take it the what is that, 1 P same as it is, what is that, the given the load, that is 150 kilonewton, so convert that into newton, that is 150 into 10 to the power of 3 divided by area. So in area you have to take the area of the concrete, so that is we have already calculated, that is 3 into 10 to the power of 4 mm square. Okay, so take that one plus PE, PE whatever you have taken. So here you have to take the one is calculated, one is P divide P, that is 150 into 10 to the power of 3 you have to take it. So here 50 into 50 they are given, One is the one is the E, they are given the eccentricity of the section, which has been initially it is been given at an eccentricity 50. So later by depth also you have to take another E, so that is PE square divided by A. So stresses in the concrete in this, it is P divided by A plus PE square divided by A. So the you will get the 50 into 50, so divided by 225, so that is I P by P square divided by I. So whatever the I value you have been determined, that is a 225 into 10 to the power of 6, that value you have to use it. So finally the stresses in the concrete you will get it around 6.66 Newton per mm square. So later you have to find out the losses of the stresses due to the elastic deformation. So elastic deformation of the concrete due to the stresses, the loss of the stress is alpha c into fc. So alpha c is the modular ratio, fc is the stresses in the concrete. You need modular ratio and stresses in the concrete. You have calculated the modular ratio earlier, it is a 6. You can substitute the value of the modular ratio as 6, and fc value you have earlier in the previous step you have determined the stresses in the concrete, that is 6.66. So totally finally the losses of the stress due to the elastic deformation of the concrete, you will get it around the 40 Newton per mm square. So finally what you have to do is you have to find out the losses of the stresses in the steel. So there is a loss of the stresses due to elastic deformation of concrete is 40, and the amount of the stresses which is there on the steel, that is 800. So 840 divided by 800, so that is a fraction you will get it, that is multipliable by the 100. So totally you will get the 5 percentage. So 5 percentage is the loss of the stresses in the steel. Okay, so that is what you have to find out the stresses in the steel. So that's about the amount of the finding the percentage of the loss of the steel, percentage of the loss of the stresses in the steel.